early in 1969, the Russian threat resurfaces. CIA satellite photos reveal 2 Soviet rockets, larger than any detected before.
Soviet Union, by whatever circumstances, had a very, very clever, aggressive space program, and they made maximum use of everything they had. When they started their very large booster, for example, our satellite photography showed that this was definitely a lunar landing vehicle.
Top secret film footage, only recently seen in the West, now confirms the scale of the Russian effort. The Soviets had constructed a massive new launch complex at the Baikonur Cosmodrome, 1,500 miles southeast of Moscow. Inside the main building, a lunar lander was under development. The Soviets, too, were planning a lunar orbit rendezvous approach to the moon. And their rocket, known as the N-1, boasted 30 engines in the first stage alone and stood 35 stories high.
They had a huge rocket, size of the Saturn, with many more engines on it than the Saturn, which they were planning to go to the moon with.
The Soviets began testing the N-1 under conditions of utmost secrecy. No one outside a tiny Soviet elite ever knew of these launches. But the CIA surveillance photos are proof enough that the race to the moon is not yet over. There is little time to savor the success of Apollo 8. Kennedy's deadline is fast approaching, and NASA's lunar lander is not yet ready to fly.
This strange device is one that Uncle Sam hopes will make history. The lunar craft will reach the moon aboard the Apollo spacecraft, and then 2 of the crew of 3 will board the bug to land on the moon.
The Lunar Excursion Module, the LEM, is designed to orbit the moon as part of a stack of spacecraft. Attached to the Command and Service Modules, the CSM. Following John Hobolt's plan, the LEM will separate off and carry 2 astronauts down to the surface of the moon. The ascent stage of the LEM will bring them back to dock with the CSM and return to Earth. At Grumman Corporation, where the LEM is still under construction, project manager Tom Kelly is feeling the heat from NASA.
Oh, terrible heat, terrible heat. We weren't ready. We were having a lot of trouble with the early LEMs, getting them to pass all their tests and trying to meet our schedules. And we were about 3 to 4 months down, despite our best efforts to try to make it up.
The LEM will never operate in Earth's atmosphere, so aerodynamics are not a problem. The problem is weight.
For every pound of weight that was brought down to the lunar surface and then back up into lunar orbit, you had to add 3 pounds of rocket propellant. So it was a 4-to-1 growth factor on weight. We went back very painstakingly through everything and cut out weight. For example, the skin, the aluminum alloy skin of the crew compartment was about 12 thousandths of an inch thick. That's equivalent to about 3 layers of Reynolds wrap that you would use in the kitchen.
Inside the crew compartment, too, everything is pared down to the bare essentials.
There were no seats. In order to save weight, we had eliminated seats. This enabled us to put the pilot's eye very close to the window so we could minimize the size of the window and still have a very wide field of view outside the window.
While engineers trim pounds from the LEM, astronauts train for a lunar landing with this contraption, known as the flying bedstead. Jet engines firing downward cancel out most of the vehicle's weight to approximate lunar gravity. But the machine is awkward and dangerous. In May 1968, astronaut Neil Armstrong, a former fighter pilot, climbs into the bedstead. Fellow astronaut Bill Anders had just completed his turn flying the ungainly machine.
It had 2 rocket fuel tanks, 2 round tanks, one on each side of the vehicle with a cross feed between them. So while Neil was up there getting the near-perfect start, fuel was draining from one tank to the other. Just about prior to touchdown, he ran out of the fuel to control the attitude of this vehicle. So now it was like a kid's balloon at a party where they blow it up and let it go.
Armstrong managed to eject just in time. But parachutes are not an option on the airless moon. The lander must work perfectly, and the landing site must hold no surprises. The moon's surface appeared fairly smooth from the vantage point of Apollo 8. Plenty of wide, flat plains where the LEM could set down safely. But close-up photos beamed back from unmanned probes tell a different story. Deep craters, towering mountains, boulders bigger than houses litter the landscape. One scientist warns that the LEM could sink beneath the surface into a thick layer of lunar dust. The landing site must be chosen with great precision and from 250,000 miles away. Charged with this task are 2 geologists, then fresh out of graduate school, Farouk Elbaz and Jim Head.
One of the big problems was if you landed even on a flat surface on the edge of a crater, some of these craters had slopes of 10 to 15 degrees in the inside. And of course, if the lunar module pitched over and landed, it would just keep going over. And that was not something you wanted to have happen because obviously you couldn't get off the moon if that were the case. So there were lots of different problems.
That would have been a really interesting one right next to here, but I'm not sure it would have been a very safe landing.
Yes.
Not the least of their problems is dealing with the competing expectations of the scientific community and NASA engineers.
The engineers wanted to do the simplest possible thing to get the person there and return them safely. And the scientists want to say, wait, we're going to be on the moon. Let's run over here, and that's going to be interesting over there. And how do we get to this? And why land in this dull, boring place? Look at the mountains. And you can imagine saying to an engineer, we don't want to land on a flat surface. We want to land on the side of a mountain. Like, whoa, get real.
The engineers prevail. The first landing attempt will aim for the edge of a broad, flat area known as Mare Tranquillitatis, the Sea of Tranquility. July 3rd, 1969. As Apollo 11 inches toward Pad 39A, the space race ends, suddenly, in a ball of fire. The CIA learns that a giant Russian N-1 moon rocket has blown up during a test launch at Baikonur. It will take the Soviets months to recover, if they ever can. NASA officials debate whether to pause and catch their breath, but all systems are go. The LEM has been trimmed down to flying weight. Just 2 days before launch, NASA gives the final go-ahead for a landing attempt. The astronauts, Neil Armstrong, Buzz Aldrin, and Mike Collins, know that many peg their chances of actually reaching the moon's surface at 50-50. If they fail, NASA has 2 more rockets and 2 more crews ready to go before decade's end. On July 16th, over 1 million people flocked to Cocoa Beach, Florida, across the bay from the launch site. The crowd is filled with politicians, television stars, Ordinary people, all hoping to witness history being made.
T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, you are confirmed to go for orbit.
The 3 Gemini veterans aboard the spacecraft have spent years preparing for this journey.
You are go for TLI, over.
Collins, a West Point graduate and career test pilot, will fly the command module around the moon. Aldrin, also from West Point with a doctorate from MIT, will join Armstrong, NASA's only civilian astronaut, in the first attempt to land on the moon.
Looks like it's going to be impossible to get away from the fact that you guys are dominating all the news back here. Even Pravda in Russia is headlining the mission and calls Neil the czar of the ship.
4 days and 250,000 miles from Earth, the crew enters lunar orbit.
You are go for LOI, over.
Roger, go for LOI.
All your systems are looking good.
Everything looks okay up here.
Going around the corner, we'll see you on the other side, over.
Going through my mind was a very simple equation in here. Today, we're either going to land, we're going to abort, or we're going to crash.
Okay, all flight controllers, gonna go for landing. Retro. Go. Rhino. Go. Guide. Go. Control.
70 miles above the moon, Armstrong and Aldrin undock the LEM and begin their descent.
Capcom, we're go for landing.
In Houston, 26-year-old Steve Bales, in charge of guidance control, anxiously awaits data to track their speed and location.
When we finally get data, I realize that we're going toward the moon 13 miles an hour faster than we should be, and the computer doesn't know it, and our ground radars tell us. And that doesn't sound like much, and yet it's almost enough that we have to abort the mission.
My trench comes up and says, hey, we're not in the position that we expect to be. We've got some velocity errors, and the one that really got your attention, we're halfway to our abort limits. So, holy cow, things are mounting in here.
Zodiac, 47 degrees.
We have a rule that says if it gets up to 20 miles an hour, we're going to stop this mission because you could actually literally crash into the moon and not know it, or you're an automatic pilot.
Their velocity stays within acceptable limits, but the trouble is far from over. In the lunar module, Neil Armstrong realizes they have overshot their intended landing site.
Maybe 3 or 4 minutes into the descent, Neil made an observation that looks like we may be a little bit long. And I thought, geez, you know, how can he possibly suspect that? But it turned out that we were a little bit long.
Only when the LEM pitches over to prepare for landing can Armstrong get a good look at the surface below, out the pilot's window. They're heading down into a field of boulders. He hits the throttle, hard.
I see the vehicle going across the surface of the moon like I have never seen it do in simulations. And I say, what has gone wrong? What's going on? It's going 5 times as fast horizontally. It's never supposed to do that. It's just supposed to gently hover down it.
100 feet, 3.5 down, 9 forward.
We knew that they were not landing where they're supposed to land. We worked on the exact landing point for so long, and we wanted this landing specifically to be very successful and safe. And here they are, not landing where they're supposed to be, and we have no idea where they will finally land, and it was really terrifying to find out that perhaps here we're going to see something that might end the program.
With a minute to go, they confront the unthinkable, an abort or even a crash. Armstrong's search for a good landing spot is using up precious fuel.
60 seconds. Lights on. Forward.
And then when 60 seconds and the light came on, and we were still not real close to the ground, we were maybe 100, 120 feet, then I guess I was getting a little concerned, but what could I do? Could I say, hey, Neil, hurry up, get it on the ground? That would just excite him a little bit more, so I couldn't say that.
Armstrong has flown 4 miles past the prime landing target. He has half a minute's worth of fuel left.
30 seconds.
You hear 60 seconds, and you hear 30 seconds. When we ever get to 0, we're going to call an abort on fuel, and the crew knows it, and we know it.
And about the time we got 30-second call, the crew said, hey, we're kicking up some dust.
Picking up some dust. Okay, 75 feet.
And we knew then that we were close. And there, I knew that no matter what I would say or do from now on, this crew was going to go in for the landing.
4 forward, drift into the right level.
So we just shut up here in the ground, and all we were doing was letting them know what their fuel status was.
And the fuel is going lower and lower. And then finally you hear contact light.
Contact light. Okay, engine stop.
We copy you down, Eagle.
Then he says something I will never forget.
Listen, Tranquility Base here. The Eagle has landed.
I didn't know what Tranquility Base was. They have never used that term when we were doing simulations. They always called themselves Eagle. So I said, what is this, Tranquility Base? And then I think, what a wonderful name. I mean, all that in a matter of 2 seconds.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Gene Kranz has no time to catch his breath. He must quickly decide. Is the spacecraft safe where it stands? Or should the crew launch from the lunar surface immediately to rejoin the command module?
We had to look over the spacecraft very quickly, make sure the spacecraft was safe, it wasn't toppling over, we hadn't damaged any of the fuel systems by blowing rocks maybe up into the lunar debris, up into the soft underside of the spacecraft. So I had to do this very quickly.
And after about 2 minutes, then it's too late, really, because if you were to lift off after 2 minutes after the normal landing, Mike Collins is going round and round, and he's too far ahead for you to catch up to him in a reasonable time.
And I just couldn't get the words out to start the stay-no-stay process, and in frustration, after a couple seconds, I wrapped my arm on my right arm on the console, and I had a pencil in my hand. I broke the pencil in two, and then got over that. It was just pure frustration. Got through it and got on with the stay-no-stay decisions until we could finally get off shift and say, my God, today we landed on the moon.
And all of a sudden, the motions of everybody came through. They all got up and clapped. Von Braun was sitting right in front of me. He turned to me and with an okay sign, he said, "Thank you, John. That's the biggest compliment I've had in my life."
That's one small step for man, one giant leap for mankind.
The most massive and concentrated effort of science and engineering since the building of the atomic bomb has paid off. The cost has been high, $20 billion, and the lives of 10 astronauts, Soviet and American. But on July 20th, 1969, only 8 years after President Kennedy committed the nation to the challenge, Neil Armstrong and Buzz Aldrin walked the surface of the moon. But what is this place they've landed on? This moon that is bigger and closer to its host planet than any other moon in our solar system. What can we learn by actually being there? About its age, its origins, its crater-torn surface. The focus of Apollo is about to change. Armstrong and Aldrin bring back precious samples from the moon that are immediately sealed away in airtight vaults. The first pieces of another world.
I was a scientist at the U.S. Geological Survey at the time, one of those chosen to study the samples, and it's 30 years ago now, but I can remember the excitement of coming here and getting our bits of material.
When the rocks first came back, it was really amazing because the rocks Neil Armstrong picked up turned out to be basalts, and the ages of those weren't a few thousand or hundreds of thousands of years, but were 3.7 billion years old, older than virtually all rocks we'd found on the Earth at that time.
Basalts like this are made from cooling lava, the holes from bubbles of escaping gas. On Earth, basalts are relatively young, as the planet's surface is constantly reshaped, erasing eons of geological history. But the age of the lunar basalts suggests that any volcanic activity on the moon ceased billions of years ago, after oceans of lava hardened, forming dark areas called maria, or seas. These rocks, before the astronauts picked them up, had lain virtually unchanged for nearly 4 billion years. Geologists are anxious for more and different samples. Even before Apollo 11, they had lobbied NASA to send a bona fide scientist to the moon. Back in 1965, a group of scientists had been selected to train as astronauts, the first who had not come up through the ranks as test pilots.
When the scientist astronauts were selected, they were all nice guys, but who needed them? You know, I mean, they can't fly. None of them knew how to fly. We had to send them to flight school.
We felt like basically they were taking up space. They didn't have the qualifications that we felt were essential, and that was to be a fighter pilot. You know, living, breathing, gung-ho fighter jock.
There were 2 MDs, 2 engineers, 1 physicist, and a PhD geologist the astronauts nicknamed Dr. Rock.
The whole idea of volunteering was with the possibility of actually taking my science and my interests to the moon.
Jack took for a long time to get through flight training. I remember at the time saying that if God had meant man to fly, it wouldn't have made him Jack Schmidt. But these guys, they were good. I mean, they were sharp people, but they were cut from a different mold. We also felt like they were, would kind of undermine the office on our official positions, which was kind of like anti-doctor, anti-scientist.
Hell, we were astronauts. We could be anything we wanted to be. We were a little arrogant. There's no question about it. And for every scientist that flew, one of us would not.
Schmidt would never be completely accepted in the test pilot fraternity, and he didn't expect to get to the moon himself. But he used whatever leverage he had to push NASA to liven up its approach to geology training.
My impression was that the pilot astronauts were bored. It was not very interesting to them.
Most of the astronauts actually hated geology. They didn't want to touch a geologist with a 10-foot pole, because their first courses in geology were taught the way I was taught geology, in a classroom with the thin sections and the microscope and learning the chemical formula of a mineral, which they will never see again or never use. And they would tell each other, I mean, we're not going to get a goddamn microscope and look at this stuff. What the hell are we doing this for?
To spark the astronauts' enthusiasm, Schmidt recruited his own source of inspiration from his days at Caltech, Dr. Lee Silver.
What I was trying to do initially was convince them that they could make important contributions to the science.
Silver led field trips for the crews of future missions, including Jim Lovell, soon to fly on Apollo 13, with Fred Hayes, and Dave Scott, scheduled to fly the following year on Apollo 15. In Iceland, they studied basalts, volcanic rock like Armstrong and Aldrin found. At Meteor Crater, Arizona, they found samples of a kind of compressed fragmented rock called breccia. Finding breccia on the lunar surface could prove that the moon's vast craters were formed not by volcanoes, as many once thought, but by the fiery bombardment of meteor impact. The astronauts must learn to recognize it.
You have to think about these people as not a typical set of undergraduates who were going out on a geology field trip. I mean, here are these people incredibly highly motivated, but also very, you know, they're very competitive. And before not too long, these people became highly motivated students because they could see that, hey, you know, you get out on the moon, we're not just going to pick up a couple of rocks. You're going to be on the moon for 7 hours, and gosh, gee whiz, that really looks neat. Goes about 30 seconds, and you got to learn some geolingo, or you're going to look stupid.
We did geology from when we woke up at dawn and could get breakfast to we'll go through 2, 3, 4 exercises a day till it got dark, and then talk geology around the campfire until 10 at night.
Fred Hayes and Jim Lovell had become so enthused about geology that they chose as their Apollo 13 motto, Ex Luna Scientia, from the moon, knowledge, and are heading for a hilly landing site, quite different from the flat terrain where Apollo 11 and then Apollo 12 had landed.
We knew that the material might be different than it is in the flat areas. We knew there was ejecta lying on the surface thrown up by volcanism or impacts that they wanted us to pick up because that could tell us a lot about the interior of the moon.
2 days after liftoff, Lunar Module Aquarius, coupled to Command Module Odyssey, is nearing the moon. Everything is going smoothly. It's become almost routine.
Trips out to the moon and back are generally very quiet, kind of boring, as a matter of fact. Crews kind of going over their checklist, etc. They had a TV day that day where the crew took everybody on a tour of the capsule and so on. And that was winding down, and they were securing from that and getting ready for sleep time.
We're just about ready to close out our inspection of Aquarius and get back to a pleasant evening at Odyssey. Good night.
Gene Kranz went around the room, says, before we put the crew to bed, is there anything you want to do before they shut down for the night? And I said, okay, Flight, what I need him to do is stop charging one of the batteries and give me a crowd stare all 4 tanks. 4 switches, all 4 tanks, no big deal.
Command Module pilot Jack Swigert throws the switches to activate fans that stir up the tanks of liquid hydrogen and oxygen. Then, suddenly, the spacecraft lurches as if struck by a meteor.
Houston, we've had a problem. We've had a BP bus undervolt.
And it was a very obvious abnormal combination of shock and initial felt motion as well as sound reverberating through the hull.
And we had a pretty large bang associated with the caution and warning there.
Warning lights indicate problems everywhere. Fuel cells dying. Maneuvering thrusters out. Oxygen tanks losing pressure.
It was not until we really saw the oxygen escaping from the rear end of our spacecraft that we realized that we were in very, very deep trouble. Then we got that sinking feeling, you know, that searing sensation in your stomach when you're in deep trouble and don't know how to get out of it.
The routine stir of liquid oxygen had somehow triggered a short circuit. The oxygen tank, which fed the electrical system, had exploded. Now 2 of the 3 command module fuel cells are nearly dead.
This is virtually a quadruple failure. And we just didn't train for that because there really was no way out of it.
We really thought that God would not be so unkind as to give us more than 1 failure at one time in one system. I knew it was an abort, that we'd lost the mission.
The original mission, exploring the lunar highlands, must now be abandoned. The new mission becomes, get the astronauts home alive.
And I'm down at the Cape, said goodbye to the guys, and I watched the launch. And then I headed for Houston. And then the word came back.
The Apollo 13 spacecraft has had a serious power supply malfunction that could cause the lunar landing mission to be terminated early.
Without question, I was disappointed. At the beginning of an experiment, you got good people working on it, you're enthused and all. Priorities are priorities. My concern was for the crew. These are people I worked with.
The command module's power supply is nearly spent. Soon its computer, lights, and gauges will be dead. The ground directs Lovell, Hayes, and Swigert to use the lunar module as their lifeboat.
We figure we've got about 15 minutes worth of power left in the command module, so we want you to start getting over in the LEM and getting some power on that.
The LEM has its own power supply, but it's designed to support 2 people for 45 hours. Now there will be 3, and they are at least 90 hours from home. Ground Control decides they should continue around the moon and take advantage of lunar gravity to turn them back toward Earth. Then, to get home before the power runs out, they must accelerate their crippled spacecraft by burning the LEM's small descent engine, an extremely critical maneuver that had never been tested.
The ground started to send up the instructions to me of how long to make the burn, what attitude, and things like that. And I had my 2 companions in the lunar module with me. When I looked at them, they weren't paying any attention at all. They had cameras in their hands. They said, well, as we go around to the far side, we're going to take some pictures. And that's when I told them that if we didn't get home, they weren't going to get them developed anyway.
Jim, you go for the burn. Go for the burn. Roger, understand. Go for the burn.
And it worked.
Ground confirms ignition.
We're burning 40%.
But as soon as it was over with, then we turned everything off. And we had only the radio and a little fan to circulate the atmosphere because we had to save power.
It got very cold and very damp. My guess is it was somewhere between 35 and 40 degrees. I started having chills and fever. It was nothing that made me incapacitated or couldn't function. It was just added to the uncomfortableness of the situation.
For 3 days, Lovell, Swigert, and the ailing Hayes huddled in the freezing lunar module. There was little to do but wait and hope their re-entry heat shield hadn't been damaged by the explosion. Then, as they approached the Earth, another potential disaster.
When the ground was tracking us, they found out that we were not inside the free return course. And the free return course is a 2-degree pie-shaped wedge that you have to come down into with respect to the Earth's atmosphere. We were beneath it, which we could have missed the atmosphere or skipped out like skipping a stone on water, and we'd be gone. So we had to make another maneuver, but our computer was down, our guidance system wasn't working, our autopilot was off, and we had to do it literally by the seat of our pants.
Lovell and Hayes set the course by eye, aiming toward the Earth, and fire the thrusters by hand to control the ship's direction. Swigert times the main engine's burn using his wristwatch. The course correction seems to have worked, but will the heat shield hold up? During re-entry, there is always a communications blackout that lasts about 3 minutes, as the spaceship heats up to over 8,000 degrees. 3 minutes pass, then 4.
The extended blackout period got us. It's the first time I came up and said, something didn't go right. And then I immediately caught myself and saying, no, it's some kind of a communications aberration. There's something wrong with the communications. This crew is coming home. I cried. As soon as I saw those parachutes, it was literally the tears flowed. And I think this was true for many of the people. I did return. I did get back from this mission. But I think it's human nature. You cannot do the the preparation and the training and have the investment in accomplishing what was in the flight plan and accomplish so little. So there was that kind of a stigma for me that, you know, we just, we didn't get it done.
The crew is safe, but everyone's great sense of relief is tempered by a growing realization that Apollo's days are numbered. Funding for Apollos 18, 19, and 20 is cut by Congress, reflecting a shift in national priorities that had begun years earlier, after President Kennedy's death.
Before we ever landed on the moon, President Johnson and President Nixon killed anything in the future. President Johnson, because he was having trouble with Vietnam and the Great Society. President Nixon, because I think he was a good politician, and the moon had gotten to be controversial even before we landed.
Scientists are determined to glean everything they possibly can from the last few Apollo flights. The new lunar rover will give them more bang for the buck. Lee Silver is delighted. Now his astronaut geologists can range several miles from their landing site and carry hundreds of pounds of samples. Dave Scott will command Apollo 15, the first to take the rover into space.
NASA actually stretched the rubber band about as far as you can go. They extended the capability of the lunar module. The propulsion system was better, the guidance was better. They added the lunar rover. We had longer duration backpacks, more consumables, more everything. So it was stretching out to the edge. And of course, you know, we get to fly them, so we were really enthusiastic.
Dave Scott is an explorer. He saw Apollo 15 as the first extensive scientific voyage. And this was a change from, you know, the space cowboys of the earlier times when, you know, pushing the envelope, being the first to do this. I mean, Dave had a real vision of what was going on, and he carried the rest of the crew, you know, with that vision and the program as well.
Scott's spacecraft 2 has been reconfigured to accommodate the push for lunar research. It's the most fuel-efficient rocket yet, able to carry the extra weight of the rover and a huge array of cameras and measuring devices.
There had been so many changes, engineering-wise, to the spacecraft that we thought that maybe something would go wrong. One day I was telling the Apollo 15 crew, I'm going to give you a copy of the Quran with the prayer to protect you. And Dave Scott said, please do, we need all the help we can get.
Elbaz needn't have worried. Apollo 15 arrived at the moon without a hitch, even though its landing site was the trickiest yet, in the lunar highlands between a long, narrow canyon called Hadley and a range of towering mountains known as the Apennines.
Hadley Apennine is certainly, in my opinion, the most spectacular landing site on the moon that we could reach. It has a rill or a canyon, has enormous mountains, 15,000 feet above you. There's so much to see. And when you've studied the area and you think you know what you're looking for, and there's much more, and it's so clear up there.
Boy, that's a big mountain when you're down here looking up, isn't it? My, oh my. Oh, look at the mountains today, Jim, when they're all sunlit. Isn't that beautiful? It really is. My golly, that's just super.
The Hadley Apennine landing site is located near Imbrium crater, so large it can be seen from the Earth. Scientists believe the crater was formed by a huge meteor impact when the moon was young. That catastrophic collision must have kicked up rock from deep inside the lunar crust. Geologists Jim Head and Lee Silver, glued to their television screens in Houston, hope Apollo 15 is in a good spot to find some of this ancient material called anorthosite.
Anorthosite, that would be the deep crust that we could look at and understand. And Dave went up to the side of the mountain and he looked over and he saw this sparkling crystals glinting at him, which is rare for the moon.
Guess what we just found? Guess what we just found? I think we found what we came for. Crystal and rock, huh? Yes, sir. You better believe it. As a matter of fact, oh boy, I think we might
might have ourselves something close to the northosite, because it's crystalline. That is really a beauty, and there's another one down there. Yeah, we'll get some of these. Back it up.
It turned out to be, we think, a sample of the original crust of the moon, made 4.5 billion years ago, right after the initial formation of the moon.
The anorthosite Dave Scott brought back is a jewel in the crown of lunar exploration, the oldest sample yet found. The press dubs it Genesis Rock. Its surprising age and chemistry, along with evidence from the other lunar samples, gradually lead to a radical new theory of the moon's origin. 4.5 billion years ago, Earth was struck by a Mars-sized asteroid. This giant impact sent a massive amount of material into orbit, which coalesced, forming the moon. The theory, ridiculed at first but now widely accepted, was developed by planetary scientist William Hartmann.
Apollo itself tied together the history of the moon with the history of the Earth, so that it made us aware that we live in this system. We're not just living on an isolated planet, but we have this neighbor, and the neighbor records the early history of the system because there's virtually no erosion there, and the Earth records the last part of the history of the system. But if you put the two together, we get the whole story.
The moon's presence changed the Earth in profound ways. Its gravitational pull stabilized the young Earth's wildly fluctuating axis of rotation, setting up the conditions for everything we take for granted about our planet. Moderate temperatures, liquid water, tides, life itself. December 1972. After 7 years of debate within NASA, a scientist will go to the moon. Geologist Jack Schmitt will fly on Apollo 17 with mission commander Gene Cernan.
There was a lot of pressure from the scientific community for a scientist to fly on Apollo before it was all over. Jack never took no for an answer. He sort of became a pain in a lot of people's butt. And it basically, Deke Slayton, our boss, got a directive that Jack Schmitt would fly on an Apollo mission. And there was only one left, and that was Apollo 17.
Three and a half years after Neil Armstrong and Buzz Aldrin had set out for man's first lunar landing, the last moonshot lights the midnight sky at Cape Kennedy. The only Apollo night launch is precisely timed so the crew can touch down in the clear light of the lunar dawn.
Okay, stand by for pitch over. Oh, are we coming in? Pitch there it is, proceeded. And there it is, Houston, there's Camelot. Wide on target, I see it.
Cernan and Schmidt's landing site is a deep, mysterious valley between the Taurus Mountains and Littrow Crater.
10 feet. Contact. Okay, Houston, the Challenger has landed.
The astronaut and the geologist are not only on the moon, they're in heaven.
I was strolling on the moon one day in the merry, merry month of December. Now, May's the month.
We were in a valley deeper than the Grand Canyon, one of extraordinary geological variability, one that we now are finally going to have a chance to explore. This is a geologist's paradise if I ever saw one.
Cernan and Schmitt have little time simply to sightsee. Nearly every minute is tightly scheduled, setting up experiments and collecting samples.
Here's a nicely structured rock that we probably ought to work on. There's a lot of lineation in some of that white material, Jack. Probably the breccia. It's got a little dust covered. Look at where the contact between the gray and right, and it's on both sides. Oh, hey, there is orange soil. I can see it from here. It's orange.
Even when they stumble upon an unexpected discovery, their time must be carefully rationed.
All right, let me put my visor up. It's still orange.
They got to leave at a certain time regardless of what we got.
Guys, we don't have that much time.
I know, Bob. I know.
You're going to leave the moon at a certain time, and you have to work everything in. And you have to get through that frustration of not having enough time to do everything you'd want.
After 3 days of 7-hour EVAs, Schmidt and Cernan have collected over 200 pounds of samples. Now their supplies of oxygen and water are nearly spent.
Gene's finished with the core tube, then we should be able to go.
Cernan and Schmidt head back to the LEM, ending the explorations of Apollo. But neither man could have guessed they would be the last moonwalkers of the 20th century.
When they write the history books and they say man landed on the moon from 1969 to 1972 and then did not go back for at least 30 years, maybe 40, maybe 50, I hope not, but maybe that long. It'd be sort of hard to explain, I guess, as a historian.
We could have run more missions, but in historical perspective, gosh, it's only been, 30 years. That isn't long. When you look at the major explorations in history, there are hundreds and 200 years between the major events. So we're regrouping now.
When I started walking up that ladder, I realized, hey, this is it. Somewhat of a nostalgic moment. You looked around, I looked back at the Earth and realized I'm never going to be here again. Somebody will, but I'm not. And I wanted to sort of leave a challenge for that, for those who would follow. And I wasn't sure what I was going to say until I said it, quite frankly. And I wanted to have our challenge, the challenge of Apollo, sort of have something to do with the destiny of those who follow. Here's the challenge. The door's open, the door's cracked. You now have the opportunity to go on from here. And, my exact words, we now leave as we once came, and God willing, as we shall return with peace and hope for all mankind. And may America's challenge of today.
Forge man's destiny of tomorrow. Godspeed the crew of Apollo 17.
The quest that began as a desperate race against the Russians at the height of the Cold War has ended. How ironic that an effort born of bitter conflict produced the most profound images ever seen of the interconnectedness of mankind and opened a window on our common origins. Ironic, too, that it ended so soon. The whole grand endeavor, barely a dozen years from start to finish. Today, the abandoned launch platforms loom like some 20th century Stonehenge, monuments to the incredible achievements of decades past. Surely man will return to the moon and venture beyond. But in the new millennium, it will most likely be private enterprise, not political necessity or even scientific curiosity that will propel the efforts. But wherever we may go in the universe, those first visits to another world, from 1969 to 1972, will always live in human memory as Chapter 1 of the Great Adventure.
This strange device is one that Uncle Sam hopes will make history. The lunar craft will reach the moon aboard the Apollo spacecraft, and then 2 of the crew of 3 will board the Bug to land on the moon.
The Lunar Excursion Module, the LEM, is designed to orbit the moon as part of a stack of spacecraft. Attached to the Command and Service Modules, the CSM. Following John Hobolt's plan, the LEM will separate off and carry 2 astronauts down to the surface of the moon. The ascent stage of the LEM will bring them back to dock with the CSM and return to Earth. At Grumman Corporation, where the LEM is still under construction, project manager Tom Kelly is feeling the heat from NASA.
Oh, terrible heat, terrible heat. We weren't ready. We were having a lot of trouble with the early LEMs.
Pared down to the bare essentials.
There were no seats. In order to save weight, we had eliminated seats. This enabled us to put the pilot's eye very close to the window so we could minimize the size of the window and still have a very wide field of view outside the window.
While engineers trim pounds from the LEM, astronauts train for a lunar landing with this contraption, known as the flying bedstead. Jet engines firing downward cancel out most of the vehicle's weight to approximate lunar gravity. But the machine is awkward and dangerous. In May 1968, astronaut Neil Armstrong, a former fighter pilot, climbs into the bedstead. Fellow astronaut Bill Anders had just completed his turn flying the ungainly machine.
It had 2 rocket fuel tanks, 2 round tanks, one on each side of the vehicle.
The Soviets had constructed a massive new launch complex at the Baikonur Cosmodrome, 1,500 miles southeast of Moscow. Inside the main building, a lunar lander was under development. The Soviets, too, were planning a lunar orbit rendezvous approach to the moon. And their rocket, known as the N1, boasted 30 engines in the first stage alone and stood 35 stories high.
They had a huge rocket, size of the Saturn, with many more engines on it than the Saturn, which they were planning to go to the moon with.
The Soviets began testing the N1 under conditions of utmost secrecy. No one outside a tiny Soviet elite ever knew of these launches. But the CIA surveillance photos are proof enough that the race to the moon is not yet over. There is little time to savor the success of Apollo 8. Kennedy's deadline is fast approaching, and NASA's lunar lander is not yet ready to fly. Early in 1969, the Russian threat resurfaces. CIA satellite photos reveal 2 Soviet rockets, larger than any detected before.
Soviet Union, by whatever circumstances, had a very, very clever, aggressive space program, and they made maximum use of everything they had. When they started their very large booster, for example, our satellite photography showed that this was definitely a lunar landing vehicle.
Top secret film footage, only recently seen in the West, now confirms the scale of the Russian effort.
Getting them to pass all their tests and trying to meet our schedules. And we were about 3 to 4 months down, despite our best efforts to try to make it up.
The LEM will never operate in Earth's atmosphere, so aerodynamics are not a problem. The problem is weight.
For every pound of weight that was brought down to the lunar surface and then back up into lunar orbit, you had to add 3 pounds of rocket propellant. So it was a 4-to-1 growth factor on weight. We went back very painstakingly through everything and cut out weight. For example, the skin, the aluminum alloy skin of the crew compartment was about 12 thousandths of an inch thick. That's equivalent to about 3 layers of Reynolds wrap that you would use in the kitchen.
Inside the crew compartment, too, everything is